So I'll copy the picture here, and we have this, and I'm going to draw the ladder in a different color. Okay, and I'm going to put the numbers in. So this is 4 between this and this feet, and this is 8 feet. Okay. So a fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. Okay, so this is the building, this is the fence, this is the distance between the fence and the building. What is the length in feet of the shortest ladder? So when I read this, I will say, first of all, I'm going to call this L, and I want to minimize L. Okay, let's go back. So why is this? Okay. So what is the length in feet of the shortest ladder that will reach from the ground over to the fence, over the fence to the wall of the building? Round your answer to 2 decimal places. So 2 decimals. Okay, perfect. So in this situation, first we have to think in terms of similar triangles. So I don't know what I'm going to get, but definitely I have to get a function. So I have to get the length of the ladder and as a function of whatever, we'll see, and then find the minimum of that. And remember, I always have to justify. I have to justify that it gives a minimum. I either study the sign of the first derivative or find the second derivative. I don't recommend that, but some of you are using it, which is fine. Find the second derivative and plug it in and see if it's positive or negative. Positive, which means a minimum. Negative, which means a maximum. We'll get to that. Okay, so I see a small triangle here, and I see a bigger triangle here. These 2 triangles are similar because they have congruent angles, equal angles. How do I know? So first of all, they are both right triangles, and they have a common angle. So they must be similar because the other pair has to be the same. Otherwise, it would not work. If 2 pairs are equal or congruent, if these are not equal, then we're not having 180 degrees as a sum of all the angles. So every time we talk, we say, so let me write, so similar triangles. So every time we talk about similar triangles, we know that there is a chain of proportions that we can write with their sides, okay? Because they are similar. Because they are similar, then these will be equal. Okay, so I start with the common angle. Common angle, the opposite of in the small triangle is 8. The opposite in the big triangle, I don't know. Moving on. The opposite of the right angle, this, I don't know. X. The opposite of the same angle in the big triangle is L. I'm moving on. Here, I don't know. So the opposite of this angle in the small triangle is W. In the big triangle, the opposite of the same angle is 4 plus W. Okay, so here I'm looking at 2 proportions. this proportion which involves L, and also maybe these two if I need to remove something else from there. Who knows? I don't know. At this point, I don't know where we're going. So slowly we'll figure it out. Okay. If I solve this proportion for L, I have 8L equals XY. 8L equals XY. If I solve this proportion for L, or doesn't matter, just cross multiply, see what I get. I get X 4 plus W equals LW. Now, notice that I have here eventually a function of one variable, but I have X, I have Y, and I have W. I have X, Y, and W. And really, I'm looking for L. So right now, I only have two equations. Is there anything else I could come up with? Yeah, I could write the Pythagorean theorem here as x squared equals 64 plus w squared. And also in the big triangle, L squared equals y squared plus 4 plus w squared. So it's kind of promising. We'll see in a minute. Because I do have 4 unknowns, and now I do have 4 equations. So let's see. From this moment on, I have to manipulate this, everything, all these 4 equations, and hopefully get L function of one of them. It may be X, it may be Y, it may be W, I don't care, but I need to manipulate all these algebraically and find L function of one variable, only one variable. So I can find L prime. I'm writing X, but maybe it may not be X. To find L prime and then study the sign. Of course, a critical number. So L prime, critical number, set equal to 0 or undefined, and then study the sign. Okay? So let's see how algebraically we get rid of everything and we just get L of a variable. That's all there is to it, because we don't have the function yet. Okay, so I'm looking to see, I don't know which will be the shortest path. I haven't looked at the problem, so so if I write from the first one, L equals xy over 8, okay. Now I would like to get rid of x and y. Is there a way of getting rid of x and y from anything else? Not of both, just either x or y. If I solve this for x, I will have the square root of 64 plus w squared. But now I need to get rid of w. Okay, let's see, where is my y? Okay, y will be here, okay? Is that the only, okay, let me look at y. So y squared equals L squared minus 4 plus w everything squared. So then y is also the square root of L squared minus 4 plus w squared. I really don't want that, because L okay, so what if I say y equals 8L divided by x? So then I have 64L squared over X squared. I'm simply trying different things. This is not something that I could get a path from the very beginning. So, okay, so what I did, I took y from here, so 8L over X. So if I put it here, and then I get L squared minus 4 plus W squared. Okay. So the only thing I need to get rid of is W. So, okay. So we'll see. Hopefully that's the key. So W squared equals this, W equals the square root of X squared minus 64. Okay, so let's see if that does the trick. Yeah, it's complicated, but it will do the trick. Okay. Okay. So now I finally have an equation with the function and only one variable. Okay, so let me go back and just explain what I did. I solved this equation for y as 8L over X. So from here, I solve for y as 8L over X, right here. Then I kept this equation as, maybe I should write it again. I guess we don't have to do anything to it. Y squared plus 4 plus W squared. I squared W, L, and I put it in here. That's even better. 64L squared over X squared plus 4 plus, and I replaced W from here as X squared minus 64 with the square root. So then I have the square root of X squared minus 64, everything squared. This is not done, it's not cleaned up yet, because I have to have just L squared on one side, or it doesn't matter really, because we're going to differentiate anyway. So I'm going to move this to the other side. And here I can even square. I have 16 plus 8, the square root of X squared minus 64 plus X squared minus 64. So the first term squared plus 2 times the first, 8 times the second, plus the second term squared. And on this side, I'm going to factor out L squared. So let's see what we have. So this is X squared plus 8, the square root of X squared minus 64. And this is minus 48, I think. Okay, so I got L squared. Yeah, not friendly calculations. Now I see why that was an issue. So L squared is a function of X indeed. And the numerator is X squared plus 8, the square root of X squared minus 64 minus 48. So we found our L of X, which is basically the square root of all this. Notice that I didn't put plus or minus because we are talking about the distance. Otherwise, he should have been there. Okay, so now I know you're going to wish me good luck to differentiate this. So what I would like to do is I would like to stay after class and differentiate this function. So find L prime, set it equal to 0 or undefined, and then finally study the sign. If that's okay with you, Quinn, is that okay if we finish this after class? Because I would like to go over more than just one problem.
Yep, that's
So
fine.
the difficult part was to write these 4 equations and mix them and match them and blah, 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 and come up with this. So what we're going to do after class, if you have time, if not, I will do it on my own. I will differentiate this function, which is not an easy thing. Because first of all, I have the square root, then I have a quotient to differentiate. And then we'll set it equal to 0. We'll see if it's ever undefined. And then we study the sign, and then we'll get the answer. But it will take me another 10 minutes to find the derivative. That's all we really needed. We really need to find the function. Once we have the function, then... Okay, so I don't want to spend too much time on just one problem. So did you understand the steps here, what I did?
Yeah, so you have to write out all of the, you have to multiply all of the different similar triangle equations together.
Well, so these two, so first of all, you see I have 1, 2, 3, 4 unknowns basically. And in order to solve for one of them or get an expression in which, or if I want to solve, I really need 4 equations. If I don't have 4 equations, I will not be able to solve, because I have 4 variables, 4 unknowns. So that's why I needed 4 equations. If I have 2 unknowns, I need 2 equations. If I have 3 unknowns, I need 3 equations. So first what I did, I wrote the proportions for similar triangles, but then I applied Pythagorean theorem in the small triangle and Pythagorean theorem in the big triangle. And from this moment on, I solved this equation for y. I solved this equation for w, which is here. And I solved the first one for y, and I solved this one for w. And what I did next was I replaced the y in here and the w in here. It may be that this one could be an easier path. I didn't even look at that equation. So here we have, let me just look for 1 second, because that will be a potentially a much easier path. So L was x 4 plus w divided by w. So that is x and 4 plus the w that we had, the square root of x squared minus 64. Yeah, I think this is a easier path. X squared minus 64. Everything divided by 4 plus the square root of x squared minus 64. No, it was just the square root. Why did I write 4? Yeah. So it was L equals x4 plus w over w. Okay, I like that. And 4 plus w, okay. So I could change this into 4x over the square root of x squared minus 64. So x times 4 over this, and x times this over this will be plus x. Ah, much nicer. Okay, so this will not take that long. So I have 1 plus, the numerator prime is 4. I'm not going to write it here because, as you know, I'm never able to finish in that little corner. Yeah. This is much shorter. I'm glad I looked. So 1 plus 4 stays outside. The top prime is 1, the square root of x squared minus 64. And then plus, why I said plus, it makes no sense. It's minus. The top is x times 1 over 2, the square root of x squared minus 64 times 2x. look at that. Good. Much better. It looks much better.